Hello and welcome to the Sage Campus webinar, Introduction to R, with our guest today, Maja Založnik. My name is Michael Todd and I'm the Social Science Communications Manager at Sage Publishing. Let me begin by introducing you to Maja. Maja is a demographer and affiliate at the Oxford Institute of Population Aging. She recently completed a postdoc at the Institute where she worked on a project exploring the implications for food production of the aging agricultural sector in Vietnam as part of the Oxford Martin School Future of Food program. Over the years, she has analyzed data sets ranging from census data to specialized surveys in the fields of demography and health at both local and global scales. She has a particular penchant for visualizing data for both exploratory analysis purposes as well as communicating results, where interactive visualizations can be particularly useful, all the while ensuring a reproducible workflow and open access to data and analysis scripts. Dr. Založnik has kindly taken on this webinar at short notice, replacing Andrea Moldovan, and we'd like to extend an extra thanks to her for this effort. She will be going over the same topics as we originally planned, from basic questions about what exactly is R and why would you use this language, to a live presentation of creating a regression model using R. Listeners who like what they are seeing and want to learn more are encouraged to use a 50% discount off Sage Campus's Introduction to R online course that we're offering in conjunction with this webinar. To get that discount, use the code IRWBNR50, it's on the screen now, IRWBNR50 when signing up. Now, this 1 hour webinar will be recorded and archived for future viewing. We will be sending out a link to you to view it and to access the slides to all registrants in the coming weeks. And if you have any problem with the audio or viewing mode during the webinar, please use the Q&A box, which is probably on the right of your screen, and one of our helpful team members will get back to you ASAP. At the end of the webinar, we'll have time for Q&A from attendances, so please also use that Q&A box to ask any questions to Maja throughout the webinar, and we'll address them during the Q&A portion. Please also take note of the webinar hashtag SageTalks, which is good for all of our webinar series, and feel free to ask questions or leave comments there. And without further ado, I will pass it over to Maja.
Hi, everyone. Thank you, Michael, for that introduction. Hopefully you can see my screen now. Welcome, everyone, to this introduction to R for Social Scientists. Here is a brief outline of what I want to talk to you about today. I will first give you a quick introduction to what exactly R is and how we use it. Then I want to give you a couple of examples of data visualization and interactivity in R, which is one of my favorite topics. Then we will switch to the demo mode, and I will give you a brief outline of what RStudio is and how we use it to interface with R. Then an even briefer introduction to the R language, and then finally the demonstration of how to create a regression model using R. So, what exactly is R and how do we use it? R is two things. It is, number one, a programming language. So called the language for statistical computing, which means it's an actual programming language. And that can be a bit scary at first, but trust me, it's worth it. Because R is also an environment for data analysis. It's a complete environment, comprehensive platform for data management, data exploration, data analysis, data visualization, as well as reporting and presenting your analysis. R has become one of the most popular platforms for data analysis, with an ever-expanding user base as well as functionality. So is it worth learning, is the question. I guess like learning anything new, learning R does take a little bit of effort, but you don't need to be a computer scientist to get it. I'm definitely not. I'm a social scientist, like I'm guessing most of you are. So we don't have a lot of time today, but I'm going to try to give you a flavor of what R is and why I'm such a fan, and hopefully encourage you to take the plunge and learn it as well. So why is it worth learning? Well, that depends partly on what your alternative is. If it's another statistical package, it's probably a commercial package. So that means you're tied to licenses, and that can be expensive. With R, you're no longer dependent on this because it is a free and open source program. It's available on Windows, Mac, and Linux. That means when you change employers, when you change universities, when you change operating systems, you don't have to worry about being able to continue your work. You'll also be able to import all sorts of data from other proprietary formats, such as Excel or SPSS data, and numerous others. You can also interface with R with other analytical tools such as Python or Julia, MATLAB. Again, there are numerous possibilities. A big advantage of R being open source is that there are that anyone can contribute to its development. That would, of course, become quickly unwieldy if you had to download everyone's contribution. So what actually happens is when you download R, you only download a base version of R, and then you can extend it by installing additional packages. That's what they're called in R, that were written by other users and again made available for free. Packages usually contain functions, sometimes they contain data sets, and we'll have a look at a couple of them in the demo later on. There is, in the official repository for R packages, which is called Pane, there's currently almost 14,000 packages, and these are all fully documented with help files and all the documentation that you might need. R also comes with a great community. This is one of my favorite parts about using the R ecosystem. More often than not, the problem that you're trying to solve was already attempted by someone else. You can easily access their code, find it online, download it as a package. You can use their functions directly. You can also use their code as a template for something that you want to do and just tweak it a little bit so you don't have to write the whole thing from scratch. And very often you can contact the authors directly with issues that you have with their code or suggest some function that you can't write yourself and you think would be a great addition to their package. In addition to that, there's loads of helpful folk on dedicated forums, mailing lists. There's also a big Twitter community using the hashtag #RStats. So that's also fun. I also want to mention reproducible research and its importance in this context. I'm a big fan. And R basically encourages you very strongly by forcing you to script all of your code to make your work a lot more reproducible. Many data analysis and data visualization tools rely on point and click actions, and that can be great, especially if you want to do something quick and dirty. But that sort of work is not reproducible, and it's also prone to error. Instead, using scripts or files with the code to conduct your analysis, it means that everything from importing the data, exploring the data, running the analysis, creating the visualizations, and preparing the reports and presentations, everything is recorded. It means you can repeat it. It means you can rerun it, be transparent about what you did with collaborators, with your peers, and probably most importantly with yourself as well. You'll be able to know exactly what you did when you go back to some analysis that you did a while ago. Finally, R has excellent data visualization capabilities. That was also the original reason why I joined the R bandwagon. I was doing categorical data analysis and wanted mosaic plots in SPSS, and they didn't exist. So I found them in R. That was over 10 years ago. So here I am now. I won't talk too much about data visualization. Instead, I'm going to show you a couple these are just like a couple of random examples from stuff that I've done, just to give you a flavor. This is a heat map, and this is pretty much out of the box. It's looking at the death rates in 14 European countries that have data going back to 1900. I like this chart because it's quite simple, but it tells quite a few stories if you look at it a bit more closely. Like you can see these are the First World War and the Second World War here, and you can compare how they affected civilians compared to men, presumably, who were serving. You can also see this really interesting diagonal line that goes up here. This is a lower mortality rate for people that were born in 1918, which is when the Spanish flu epidemic was raging. So it's an interesting little thing to notice. Another example is this is a more bespoke example that I did for a publication that needed to be published in black and white, and I quite like it. It is of African governments and their views on population growth and policies. So you've got the whole sub-Saharan Africa here on the left, and then you can see each individual region on the right. So for example, you can see that most Southern African countries now think that their population growth rates are satisfactory or even too low, while the rest of sub-Saharan Africa is slowly coming towards the position that their rates are too high. Another example here we have of a map, a growth map. R can do all sorts of spatial analysis you want, including mapping. This is a bit of a bespoke map as well.
Maja, sorry to interrupt quickly. We've had a couple of comments saying they can't see your screen. I can see my screen, so I think a few of you might have minimized the window. Can you just see the webcam? Do people mind commenting if they couldn't see this, if they can't see the screen? No? Is it just two? So most people can see all fine. Okay, Joshua and Michael, I'll reply to you separately. Sorry, Maja, carry on.
No problem. Thank you, Amy. Okay, I'm glad most of you can see what I'm showing you. Otherwise, this would have been quite odd. So yeah, where was I? This is a mapping UK households on the UK census from 2001, proportion of people that own 2 and more cars. I was able to do a little zoom in of London here, and my favorite thing is this little neat density curve under the legend, giving you an idea of the overall distribution. Another example, this is a stacked bar chart where I was comparing household living arrangement of people over 60 each. So the question is what types of households they live in. Are they 1 generation, 2 generation, maybe skip generation, and can compare men and women here in the 2 bars. Then on the background, I also did the country average, so it's easy to compare. Another example of things you can do in R are animations, and being a demographer, population pyramids are one of my favorite things. So here is a population pyramid for Korea and how it changes over time, and you can see the year in the top right-hand corner. This is perhaps not super useful from a scientific point of view, but a GIF like this on Twitter can attract probably more attention than a link to a PDF publication. So it's maybe not the worst skill in the world to acquire. And finally, interactivity. This is also a thing that's more recent, maybe a bit of a more recent advancement in R. So this is an example of a chart that I did in R, and it's a bit busy. It's not really, it's like 14 provinces in Vietnam and farming sizes of different households. So instead, I decided to try a, let's see if this will work, an interactive chart. This was actually the first interactive chart that I did in R. So, oh, what happened here? Let's see if this works. If not, okay, maybe we'll skip this. No, oh, here it is. Just give it a second. Okay, so now this is the same data, the same chart that I had before, but now I can see individual provinces one by one. Little drop-down menu, I can switch between them. The map updates as well to show me exactly where these provinces are. I can also sort the farm sizes. Now they're sorted by total cropland. I can sort them by the size of their rice area, etc. You get the idea. Let me go back to my presentation. If I get this to work. Okay, there we are. So let me put it into full screen mode as well. Okay, so these are just a couple of examples that I've done. There's loads more examples. I highly recommend that you look at the R Graph Gallery, which has loads of examples of regular charts in R, including the code that you need to create them. And for the interactive graphics, which are done with a package called Shiny, there's a Shiny gallery which also shows you large amounts of examples for interactive graphics, including dashboards, which you might also find interesting. So next thing is to move on to RStudio. I want to just quickly do a bit of a terminology session. So the difference between R and RStudio. R is, like I said, the programming language and the suite of software facilities for data analysis and visualization. Once you install R, you can use it immediately, but you'll be using it from a rather basic console. Instead, you'll find interacting with R a lot more familiar if you use RStudio. RStudio is an integrated development environment. It's called an IDE for using R. There are several other ones, and you're welcome to explore them. You can also use R from Emacs or Vim if that's what you use. There's no problem with that. But RStudio has become quite a leader in the field, and it integrates many of the functions which make R easy to enhance your reproducible workflow. And yeah, it makes it easy to do everything you would normally do, but also makes it easy to do things like write reports, presentations, do interactive visualizations, like I just said. So that's what we'll be using in this demo. Instead of talking about the RStudio layout at this point, it's probably best if I just switch to RStudio and show you what it looks like. So let's do that now. So this is a pretty fresh install of R, both R and RStudio on a Windows machine. So this is what it looks like. Let's start here on the left-hand side. This is the console, and this is where the magic happens, so to speak. This little greater than sign is the prompt. Anything that I type here, oops. I type 1 + 5 and press enter, R will evaluate, and obviously the answer is 6. Now, the console is not where we would normally, of course you can always type code into the console, but anything that you write there, you'll forget. So instead, we're going to open an R script, which opens up here in the top left-hand side. And now when we type code over here, we can send it to the R console by either highlighting it and clicking run over here. You actually don't have to highlight it. As long as your cursor is somewhere in the line of code, it will highlight, it will run it. This keyboard shortcut, which is what I tend to use, is Control Enter. So that's what I'll be doing most of the time. I will try to be clear when I am running it so that I warn you. But this is me pressing Control Enter, or rather Command Enter if you're on a Mac, and this is how it prints out in the console. Let's have a quick look at the other panes as well. On the top right-hand corner is the environment pane. This is where the elements, the objects in our workspace are going to show up. Right now, the environment is empty. There's also a history pane, which tracks all of your history, which can sometimes be useful. The connections pane, I'm actually not sure. I've never used it. But let's go down here. So here we've got the file browser. The plots tab is where the plots are going to show up when we do some. All the packages that are available for me to install right now are listed here. And here's the help tab, which we're going to have a look at later as well. And there's a viewer as well. This is usually used for interactive graphics and HTML files. So now let's have a quick look at some R code. This is just to give you a very brief idea of how it's written and to make it a little bit less unfamiliar when we get to the regression demo. So first thing first, I will save this file just so we don't ruin my desktop, because that's good practice. So this is intro. And our script files have the extension .r. So let me save that there. Second thing that is very good practice is to always, oh, sorry, I need to switch this there. is to always comment your code. Comments in R work by adding a hash in front. So this is so that we know what's happening now. Right now, I'm going to tell you about variable assignment. So the way variable assignment works in R is by typing the name of a variable and then using the assignment operator, which is these two symbols, smaller than and a dash, a hyphen, and then assigning it a value. So if I type this, highlight it and Control Enter, you can see that nothing's actually happened in the console, but you've probably noticed that in the environment, the object height has now turned up. So R now knows that we have a variable called height. If I just type this in and run it, I get the value of it, which is 18. So now I can add width and make the width 4. I'm going to do Control Enter. There you go. You see the other object up here as well. And now we can use these variables to do some math. For example, height times width and Control Enter. Oops. Ha. That's me, my bad typing skills. There we go. So yeah, you can see R gave a pretty informative error. The object widht was not found because, of course, it doesn't exist. But if I correct that spelling and try running this again, there we go. The area of this rectangle is 72. Of course, it would make more sense if I did this. I'm just going to copy paste this code because I'm lazy. So area assigned to the variable area of the product height and width. And now we have, oops, area. Oh, also, you'll notice that RStudio is super fun and useful in letting me autocomplete stuff when it guesses where I'm going. So the variable area has the value of 72. So you don't normally work with single numbers, but with variables, especially if you're a social scientist. So next thing, we're going to look at how variables are represented in R. The way they're represented is using vectors. So there are a couple of types of vectors. We're just going to look at 3 right now. One is numeric vectors. So let's do a numeric vector. The way you create vectors is by using the function c. I'll talk about functions in a second, but just bear with me right now. So the function c, and now I'm just going to list a couple of values. And c stands for either combine or concatenate. And when I run this, I now have created vector 1. You can see it in the workspace up here. You can see that it's numeric and it has five elements. Let's create a couple more, or rather, let's do one more. Vector 2. Again, C. Let's make this one year of birth or something similar. Oops. 38. There we go. Control Enter, and vector 2 is again now in our workspace. I'll just clear this a little bit. So the next type of vector that is very common is a string vector. So string vectors, string vectors, again, it's a very similar setup. The only difference is that to tell R that we're using strings, we use parentheses. So if I just write a couple of names, oops, there we go. So I should also say that all code in R is case sensitive, so you want to be careful about that, or rather make it a habit to remember stuff like that. So there we've got a third vector, and then the final type of vectors are logical vectors. Oops. So let's do the logical vector again. Combine the following: true, false. Oops. True, false. And there we go. Let's run this as well, and now we've got 4 vectors in our workspace. You may have noticed that all of the vectors are of the same data type. Actually, you cannot mixed data types in vectors in R. If you try, let's try if we say 5. So what will happen, there won't be an error, but R is going to do something different. R is going to reduce the, what's the word, everything to the lowest common denominator. In this case, it's strings, so it's going to change the 2 and the 4 into character vectors. So this vector 5 here now you see is a character vector. So that'll become clear just in a little bit why this is important. So the next thing I want to talk about are functions. We've already been introduced to one function. This was the C function that creates vectors. There's probably innumerable functions in R. A lot of them are in base R. So for example, a common one is mean. So let's calculate the mean of vector 1. And I'm just going to highlight this, enter. The mean of the vector is 24.6. This is a simple function that takes this argument of the vector. You also have functions that take more than one argument. For example, rnorm is a function that gives you random numbers from the normal distribution. You can have a look at the help here just to give you an idea of what the help looks like. You have to navigate this quite often. So it gives you a random generation, randomly generated numbers from the normal distribution. This is the one that we're looking at. So explained down here. So we've got n is the number of observations we want, and then it will take them from a standard normal with a mean of 0 and a standard deviation of 1, unless we change something. So that means if I do rnorm 10, I will get 10 numbers from a standard normal distribution. If I, let me just copy this, paste this. If I add a second argument, for example, 5, R will automatically know that this is the second argument, that means that is the mean. So it will now give me 10 numbers from a random distribution with a mean of 5, and the standard deviation is still 1. Let me copy this again. We can also change the standard deviation to 100, let's say. And again, we've got these numbers down here. Of course, there are many more, what I was mentioning before about packages, that's where you get specialized functions that you might need. But of course, you can also write your own functions, which is very powerful and one of the best things about R, how it lets you speed up things and automate them. But we don't have time to go into too much detail about that. So this is just so you know that is a possibility. So let's press on. So yeah, as social scientists, the thing that you're probably missing right now when it comes to data analysis is a table of data. So data tables in R take the form of data frames. So let's have a look at what a data frame is. A data frame, make some more space. A data frame in R is actually just a collection of vectors, as long as they're all of the same length. So this probably makes sense before I was saying about vectors only taking in a single data type. So each vector is essentially a column in the data frame and is a variable. So this is how you create a data frame. You use the function data frame, not surprisingly. And I'm just using RStudio's autocomplete here. So if I say vector 1, vector 2, vector 3, and I run this line, you can see down in the console, I've got a little table here with 3 columns. Vector 1 is the first column, 2 and 3. There we go. Of course, I would probably actually like this data frame to look a little bit different. So let me try do it like this. So for one, I don't like the columns being called vector 1, vector 2, and vector 3 because they're not very informative. Instead, let's start with the first column being name, and name is vector 3, right? And then the second one, let's call it year born, and that was vector 2. And the third one is going to be, let's say those numbers are the rock, paper, scissors score of each of these individuals. That's vector 1. And we've still got the logical vector, right? Vector 4. And that will be whether or not the person likes white chocolate or not. That's vector 4. So now if I run this again, see this is a slightly nicer table with column headings that make sense. Of course, this is I've just run this and output to the console, so this isn't saved anywhere. We need to assign this to my data frame. There we go. And now I run this whole bit. And now nothing showed up in the console, but my data frame has showed up here in the workspace. So let me click on this. And if I click on that, a new tab opens here and lets me view the table in a more familiar format. So yeah, you can view your data tables up here, but of course you cannot change them. So I can't type anything here. This is just a viewer. So let's just now do quickly, now that we have a data frame, let's do a quick plot, just so you see how simple and easy it can be. Yeah, I should have mentioned this. So we now have these columns. They're called name, year born, RPS, and white chocolate. In order to access them, so in order to access columns that are within a data frame, the notation that you use in R is you use the $sign. So you type my data frame, $, and then RPS, for example. See, R very helpfully gave me what my options were. If I run this, R extracts just that column, or rather the vector of values. So that's what the $sign means. So we can use this now to plot a very simple scatter plot of this is the first one. RPS, and then my data frame, $sign, year born. And when I run this, the plot tab has opened. There we go. Let me just adjust this, and there we have our very first plot. This is very basic. You can do so. Obviously, I've shown you what you can do, but you can do a lot more. By even let's change make sure the labels are properly. So this was, oh, sorry, I've got them the wrong way around. Ha ha ha. Look at me. Okay, got X and Y. I'm just gonna copy this. What I wanted to do is have X and Y like so that X should be year. Let's see if this is what I was after. There we go, that's better. So on the x-axis we have the year, and on the y-axis, x lab equals rock, paper, scissors. There we go. You can also change the color of the points and the symbols that are used. So the symbols, argument for the symbols is PCH. I'm going to switch that to 19, and let's do the color red. So there we go. Now we have the labels and the symbols changed. So this was just a very quick overview, just to make sure that you're not that the next section isn't too onerous, because I want to switch to the regression bit right now. So let me save this. In order not to bore you too much with my horrible typing skills, I have already written out the code for the regression bit, and I'm just going to open it now. There we go. And we're going to run through that instead of me typing it out. There we go. So, let me just also restart the session so that we have a nice clean blank slate. I'm going to restart R here. So that now you see that the environment is now empty. there's no plots, and we can start looking at some regressions. So first of all, the data that I want to look at is the Gapminder data. So that handily comes as a package. So I'm just going to run this bit of code, library and Gapminder. And now, silently, the Gapminder data has been loaded. You'll notice that it's not in the workspace. It's because package data. Let me just show you. Oh, sorry, I'll show you this in a second. Let me just load the other packages that we're going to need here. These are packages for plotting, because I want to use ggplot for plotting as opposed to the base graphics that we were using before. Partly because, well, ggplot has become more and more popular in recent years. I'm actually, all the examples that I showed you before are using base R. I've been a big fan of base R and have used it to my advantage for many years, but I'm slowly becoming convinced that maybe ggplot is, it's a very different style of writing code and writing and drawing plots, but I think you'll see by the end that it has quite a few possibilities, especially when it comes to interactive graphics. So, okay, let's first inspect the data that we have just imported with the package. The function head takes the top, usually six rows of the data and just prints them out in the console, so you can have a quick look at what we have. We have 6 columns: country, continent, year, life expectancy, population, and GDP per capita. At this point is when I wanted to show you that we can find the Gapminder table up here as well, and if we click on it, it will open as a viewer like I was showing you before, so you can have more of a dig around the data here. You can also use a variety of functions to inspect the data. For example, if you want to see what is the smallest year that we have, sorry, the lowest number, the oldest year that we have data for, you can use the function min. You can also, if you've not guessed, you can also use the function max. I'm just going to copy paste lazily to get the maximum. So yeah, so we have data from 1952 to 2007. Actually, if I click on this little arrow here, that will also give me a quick overview of what the data is. So again, we can see one row for each of the columns. And from here, we can see that country has 142 levels. That means there are 142 different countries in our data set. We have 5 different continents. The year we just looked at what the range was, and then the other 3 are sort of raw data numbers. Okay, so let's have a quick plot of this data. I'm going to open this up so there's a bigger room for the plot. So like I said, we're going to be using ggplot for the plots in this regression session. It's the syntax is a little bit odd, but you'll get used to it. And if you're starting in R, I recommend that you start getting used to it from the start, because it'll definitely pay back. So what's going on here is this function is using the Gapminder data, and then this stands for aesthetics. The aesthetics here are the X and the Y axes, and then we're using points. So because it's a scatter plot, I want the geom point to show the data in. So this is what it looks like, because all of the, obviously, each individual year, all the points are stacked up quite close. What I can do is add geom for jitter. Oops, jitter. And say I want width to be 1. And let's try running this again. This will give us a bit. There we go. That looks a bit. You get a better idea of the density of these data points if you use jitter. So this is just a visualization trick. Okay, so we've got life expectancy and how it changes by year. Let's try to fit a simple bivariate regression model to this. So we're in this section right now. So the way you fit a linear model in R is to use the function lm. In order to fit a model, you need to give it the formula. The formula format looks like this. So we have the dependent variable on the left, followed by a tilde sign, and then on the right-hand side are the predictors. And in this case, we only have year as a single predictor. And this is obviously the data, the table where we're taking this from. So when I run this, probably guess that nothing too obvious is going to happen, except that the object reg1 is going to show up. Oops, sorry, yeah, it will show up in the global environment. There we go. So that's where the regression is the object with all the results of the regression is now up here. If we want to inspect what we've just done, we can use the summary function. This is the classic way of inspecting a regression output. It's a bit busy, so let me just quickly, at the top, you've got the formula, how we got to this regression, then the distribution of the residuals. Here we've got the coefficients and their standard errors, p-values and p-values. Down here, this is probably what you want to look at, is the r-squared and the adjusted r-squared. Now, I actually only realized I found this out quite recently. Instead of this summary, you can also use from a package called Broom, which you will notice I loaded up here. There's a couple of very useful functions called tidy and glance. And tidy and glance, tidy takes out only the coefficients, so it creates a much smaller and more compact table so you pass it the regression object and you get only the coefficients. And glance similarly takes out the diagnostics for this model. So here we can see r-squared and everything from the Bayesian information criterion, all the statistics you might be interested in. So I think these are actually, because this original output can be a bit busy if you're actually just looking at r-squared, then glance is probably a neater, quicker way to look at it. In order to plot this regression line, we will use the same code that we had for the previous plot and now just add this extra geom smooth at the end using the ln method. That means a linear model. So if I run this, we have, there we go, our very first regression model and the line. So let's do a quick second one. This time I am doing the same, except instead of year, the predictor is GDP per capita. If I have a look, let's just look at the r-squared really. But the r-squared, so about a third of the variance in life expectancy is explained by GDP per capita. And if we do a plot of this model, you quickly see what the problem here is. Because we're using GDP per capita, that variable is incredibly right skewed and it's not appropriate for a linear model like that. So instead, what we want to do is take the logarithm of GDP per capita. So let's try this. So regression 3 is the same as regression 2. All I've changed is I've added the function log10 to the GDP per capita variable. And now let's have a look. Let's have a glance at the results. And now there you go. We have 2/3 of the variance is explained by the log of the GDP per capita. And if we plot that model, it also looks a little bit more like what we would expect. So I want to just quickly skip a couple of steps and show you a multiple regression. So like I said before, the formula for regression is the dependent variable, tilde, and then the predictors, and you can add them with a plus sign as many as you would like. But I want to do one with an interaction term and use the continent as a categorical variable. So we're going to look at how life expectancy varies by GDP and how that interaction changes by continent. Therefore, that's why we've got this asterisk here. And let's run this model. So that basically means that each subgroup of countries, each continent of countries basically gets their own linear model, so their own slope and intercept. So if, whoops, oh, sorry, I I skipped one bit of line. So yeah, in order to make this a little bit clearer, I also am looking only at the subset of the data in 2007, so not the whole data set anymore, but I will use the function subset to take only the rows in the data set, the data from 2007. There we go. I've created a new object here. This table, if I have a look, this table now only has 142 rows, so each country is in it exactly once in 2007. So now that we have the data, we can try to fit this model to it. And let's have a look at what the coefficients look like. Now, of course, there's going to be loads of coefficients. We've got, so Africa is the baseline, so the intercept and the slope for that, and then the additional intercepts and additional slopes for each of the other 4 continents. So let's have a glance at the fit of the model, and now we have 3/4 of the variance explained. And let's finally plot this. So again, this is the same as before. The only difference is that now I add color equals continent over here. Oops, sorry, here. So that tells R to group the data by continent, and it should give a separate regression line for each of the subgroups as well. So there you have it. Yeah, exactly. So, of course, this is just like I said for 2007. We could repeat this for each of the individual years, get a different chart. We could also have a glance at the data, or this next bit of code. I'm not going to actually bother too much explaining it, but because it's a bit complicated. But what it's actually doing is taking the whole table, splitting it into subtables by year, running this regression that we had on each of the subtables, and then getting a glance at them, and then putting them back out into a single table. So let's run this and see what we get. So this is now the summary statistics for all 12 regressions, so 1 for each year in the data set. You see the years over here, the R squared, and all the other. This is just a quick view, so you can't see the other columns, but they're all here, including the Bayesian information criteria and whatever other diagnostics you might be interested in. And similarly, if we wanted to visualize all of these 12 regressions at the same time, we can create a little interactive plot using Plotly. So this is again similar code as before, only now I'm adding the frame. So each year is going to be a separate frame. I'm going to save this as an object called GG, and then I'm going to create this interactive plot by entering GG into ggplotly, and let's see what happens when I do this. This should open in the viewer because it's not a regular plot. There we go. So what do we have here? So we have, this is in 1952, the regressions for all of the countries then. You see if I hover over a point, it shows me which one is this. Kuwait is this outlier out here. So that's super practical. I can see which countries are which. And then the best, most fun thing is I can press play and see how this has changed over time. And actually, because we have data on the population size, I'm going to change this plot to make sure that the points sizes change with the population. So let me run this whole thing again and see. Right, so now the points are different sizes. You can see China over here is large, and when I play this, you can see, there you go. This is Hans Rosling was the original inventor of this chart. It's called a bubble chart. And you can even here, if you have a look, you see how China goes up and down and up. That was the Great Leap Forward. They lost a big chunk of life expectancy. Right, so this is the end of the regression But this is also pretty much the end of my talk. The only thing I wanted to show you is I'm going to go just quickly back to the presentation. So this presentation, if we'd continued, actually all the code and everything that I've shown you now is also here in this presentation. This is an HTML file, everything including this at the end. And the reason why I'm showing you this is because I created it completely and wholly in R. Let me show you the file. Sorry, this is what the file looks like. These are the slides, three dashes, starts a new slide. All of this, including the code, including all of my presenter notes, are all in this one file. Let's go towards the end. This is where these are all the regressions that I just ran. All of this is in one single file, and R combines it into a PowerPoint, an HTML presentation, which opens in any browser, just like I was showing you now. And then that's like one of my favorite things in the end, is being able to combine code and presentations like this, and you can do the same writing to PDF reports or even whole papers. Sort of brings the whole thing together from one workspace. So that was me for now. I hope I gave you a good flavor of why I find R so exciting, and I'm going to switch back to Michael and see if you guys have any questions for me. Thanks.
Thank you so much, Dr. Založnik, for this great introduction to R. So we're going to address some of the questions that we had from the audience. Go ahead and continue to send them in using the question box on our right side of the screen, or on Twitter using hashtag SageTalks. And if we can't get to your question by the end of the hour, which is fast approaching, Maja has agreed to address them in a follow-up blog post on the Sage Campus blog and also on methodspace.com. And we'll also, in that blog post, include some of those links that you had that we saw earlier, and some of the recommendations for different products. So the very quick thing, and you just addressed it, but it just, so exporting that it looks like it's a fairly trivial, saving and exporting using that looks like it's fairly easy.
The presentation, you mean?
Yeah, the presentation and the analysis that you did.
Yeah. So this presentation was saved to an HTML file. So that means that you can open it in a browser. You can also upload it online, so you don't even have to have it on a USB if you have access. And like I said, you can also save. R lets you write, combine code and text, and then compile to several different formats, including PDF, which basically looks like a very nice LaTeX. If anyone is familiar with what LaTeX files look like, that's what you can get out of R, including your plots and your charts and your tables that you did. You can also compile to Word documents, which is a relatively recent thing, but also works great. I'm not sure if you can do actual PowerPoint presentations. It's possible. I tend to use PDF or HTML. But yeah, it's very straightforward and very easy.
And then how about the data that you import? First off, for example, you had the material from gapminder.org, which was coming in. Do I have to do anything unusual to import my data, or just any kind of CSV, Excel, etc.?
Yeah, so that's a great question. So standard data formats, which CSV is the prime one of them, is super easy. Most other, you basically just, there's a function that says read CSV, and it'll import. You can adjust if you have several headers. That's just an extra argument. So that's super easy. It's relatively easy to import all the others, SPSS, Excel, etc. The only thing I would mention there is that because all of these other programs are commercial programs, whenever they come out with new updates, there might be a little bit of a lag before the R functions update to be able to import this again. But it's usually very quickly solved. That's the open source community in R quickly updates, because obviously Microsoft or IBM for SPSS, they have no intrinsic motivation to make their formats easily readable to other programs, but they are always readable in the end. Yeah.
So you, at the very beginning, you talked about how the different packages are, and as you just suggested again, now are kind of proprietary packages versus R, which is open source. But is there any other key reason why I might use R apart from that?
I can honestly, off the top of my head, I cannot think of a single thing that R cannot do in data analysis. There is probably like extreme machine learning parallelisms that and even then you can use R. You can interface with Python or Julia through R. So you're really not gonna find any reasons that way. Data visualization, again, like this is my favorite thing. I think is extremely powerful. You can do so much bespoke stuff, and it's a very fast developing field as well, a fast developing community. So it's a very exciting place to be, I think.
You mentioned the 14. I think if the number was 14,000 packages, which does sound like it can pretty much do anything or is being engineered to do anything. What do I get when I go to wherever I get R, which is actually a good question. Where do I get R? And B, what do I get? What is my bog standard package?
So you get R at CRAN website, which is the Comprehensive R Network something.
Well, we'll have the link.
Sure. CRAN is the link, yeah, where you can download R, and then RStudio is a separate thing that you need to download, like I said, and you do that in that order. The bog standard R is for most cases is actually more than enough. The thing with packages is that they just make some things more efficient. So if you write your own functions, you can do pretty much anything in R. Packages just mean someone else has already written the function for you, so you don't have to reinvent the wheel. That's when it comes to functions. Obviously, like we've seen, some packages also just include data, and that's just a convenient way to access data instead of downloading it. But yeah, it's probably like, this is probably one of the disadvantages of R, is just it can be overwhelming in how many packages and how much stuff is out there, and how easy it is to find sometimes if you don't know exactly how to call something or what exactly it is you're looking for. The terminology can be tricky. Then you have to be a Google master to sometimes find. But this can be quite niche things. And like I said, the community is really supportive, so you can always ask a question on Stack Overflow, or RStudio has its own community forums, and there's going to be loads of people there happy to help and direct you towards the right package.
So this was labeled as an introduction to R, and I'm wondering, when you were at the point where you were doing your own introduction to R, to the point where you were actually comfortable using it and talking about it with other people and evangelizing for it, how long was that process, and how difficult was it?
That's a tricky question, because the time that I was doing this was over 10 years ago. It was there was no one in my department that was using R. I had to basically figure it out on my own, and we didn't have the copious amounts of tutorials and blog posts and all this material that is available today. So I probably took a bit longer than you would nowadays, because now it's just so much easier. And RStudio exists now. It did not exist back then. And that just also, again, makes it a lot easier. I completed my PhD, so if that's the question, it was with enough time to be able to master it enough to do some pretty complex. I was doing simulations, computer simulations for of UK census data. So yeah, it's totally manageable, and I have a completely social science background. I did international relations as my undergraduate degree, so. If that's at all helpful.
Well, thank you so much. And I think that's pretty much all that we have time for today. And so I want to thank everyone for joining us, and a special thank you to our speaker, of course, Maja Založnik of the Oxford Institute of Population Aging. and again for stepping up with tremendously short notice to do this. So as I mentioned earlier, we're offering a 50% discount off Sage Campus's Introduction to R online course in conjunction with this webinar. And to get that discount, use the code IRWBNR50 when signing up. In the coming weeks, be on the lookout for an email that includes a link to view the entire webinar and slides. And I know we've had a lot of questions about that. So they all will be there, and especially if you've had some difficulty seeing some of the slides or some of the presentation, it will be visible there. And we'll also have answers to some of the questions that we did not have time to get to today that will appear on the Sage Campus blog and also on methodspace.com. And please stay connected with us on the Sage Campus blog for information about upcoming webinars on different different subjects. So thank you so very much, and Maja, thank you so very much for being with us today.
Thank you, Michael.